first thing I want to do is establish what my variables are going to look like. So I'm going to use A to represent adult tickets, and I'm going to use S to represent student tickets. Okay. Now, when we put these problems together, we're going to go to now these totals. And what I need to recognize is 400 tickets sold. It doesn't matter whether they're adult or student. They're just tickets in that equation. So it's A plus S equals 400. And you're going to find in most of our word problems in this unit that just adding the two variables together is usually going to be one of your equations. Then we deal with the revenue. $7 in adult tickets, so 7 times the amount of adult tickets I sell, plus $4 student tickets, so $4 times the student tickets I sell, gives me a total of $2,350. And essentially now I set up systems of equations. While you could do it by substitution, I'm a big fan of linear combination. So I'm going to multiply the top here by -4, and I'm going to be left with -4a minus 4s equals -1600. Down here, I don't need to do anything, because I already have the 4s there. Now, you have a calculator. There's no need to be careless here. -4 and 7 is 3a. The s's cancel, and -1600 and 2350 combines to be 750. We divide both sides by 3, and my A equals 250. Now, if you want to write it out, you can. If you can do it in your head, I am okay with it being done in your head. You subtract 250 on both sides here, and the student tickets is 150. So my answer is adult tickets are 250, student tickets were 150. So I sold 250 adult tickets, and I sold 150 student tickets. So in this case here, I'm going to make box A, box A is going to be represented by the letter A, and box B is going to be represented by the letter B. There's 21 boxes. Doesn't matter their weights. A plus B equals 21. But in terms of their weights and total weight, box A is 45 pounds. So 45 times however many A boxes there are, plus the 65-pound B boxes, so 65 times however many B boxes there are, gets me to a total weight of 1,205. Once again, I'm going to do systems of equations. I'm going to multiply the top here by -45. So -45A minus 45B, and -45 times 21 is a -945. 45A plus 65B equals 1205. The A's cancel. We're left with 20B equals 260. We divide 20, and our B is equal to 13. Okay, I'm just going to do this one in my head. If B is 13, what plus 13 would give me 21? It's 8. And that's my answer. All right, so from a space standpoint, we're going to have to do the work down here. Okay, and with that being said, so the first thing I'm going to do is I'm going to solve for y in both my equations, or my inequalities. So 2x plus 3y is less than 9, and 4x minus 5y is greater than or equal to 10. So I'm going to subtract 2x on both sides. And I'm going to be left with 3y is less than -2x plus 9. And then I'm dividing everything by 3. -2/3 goes in front of the x, and 9 over 3 is +3. We want to split that denominator up. Okay. For the 4x minus 5y is greater than or equal to 10, I'm subtracting 4x on both sides. -5y is greater than or equal to -4x plus 10. And then we're dividing everything by a -5. So when we divide by a -5, it flips the inequality. -4 over -5 is 4/5. And then 10 over a -5 is a -2. And these are the two lines I'm graphing. So 3 is my y-intercept, negative 2/3 is my slope. 3 is the y-intercept, negative 2/3. That's up to left 3, up to left 3, up to left 3. Down to right 3, down to right 3, down to right 3. And since it's a less than, it is a dotted line. Now, when I graph the second equation, negative 2 is the y-intercept, 4/5 is the slope. Starting point of negative 2. 4/5, 1, 2, 3, 4, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Down 1, 2, 3, 4, left 5. This is a greater than or equal to sign. So this is a solid line. And now we need to shade. When I shade, I like to go to the original. 0.00 here, 2 times 0 plus 3 times 0 is 0. 0 is less than 9. That creates a true statement. So I am going to shade toward my point of 0, 0. In case we're wondering, here's our point of 0, 0. Here, 0, 0, 4 times 0 minus 5 times 0, 0. 0 is not greater than 10. That creates a false statement. So here we're going to shade away from 0, 0. And the double shaded region is right here. If you want to check your work, pick a point in the double shaded region. I like 0, negative 10. 2 times 0 plus 3 times negative 10 is negative 30. Negative 30 is less than 9. 4 times 0, negative 5 times negative 10 is a positive 50. 50 is greater than 10. Therefore, my answer must be correct. When you hand this in, you should literally be able to tell me whether you got it right or wrong. Now, my next one is 5x minus 2y is less than or equal to 6. 2x plus 3y is greater than 15. You subtract 5x on both sides. Negative 2y is less than or equal to negative 5x plus 6. You divide by negative 2, you divide by negative 2. When you divide by that negative, you flip the inequality. 5 has x minus 3. Here, you subtract 2x on both sides. 3y is greater than negative 2x plus 15. You divide by 3, you divide by 3. Y is greater than negative 2/3 x plus 5. And there's our answers in terms of graphing our lines. Now, when I go to graph the lines, the first one, a y-intercept of negative 3 and a slope of 5 halves. Here's my y-intercept of negative 3, slope of 5 halves. 1, 2, 3, 4, 5 over 2. 1, 2, 3, 4, 5 over 2. 1, 2, 3, 4, 5, left 2. And that's going to be a solid line because it's less than or equal to. Okay? The second one, negative 2/3 x plus 5. 1, 2, 3, 4, 5. Up 2, left 3. Up 2, left 3. Down 2, right 3. Down 2, right 3. Down 2, right 3. And this is a dotted line. Okay. And now we need to go into our shading. 0, 0. 5 times 0 minus 2 times 0 is 0. 0 is less than 6. That's true. Okay, so I am going to shade toward my 0, 0. Here's my 0, 0 point. I know it's close. We shade toward it. Zero, 0 creates a false statement here. 2 times 0 plus 3 times 0 is 0. 0 is not greater than 15. So that's false. So this one we shade away. Here's my answer. Try 0, 10 to check your work. 5 times 0, negative 2 times 10 is negative 20. That's less than 6. 2 times 0 plus 3 times 10, that's 30. That's greater than 15. Therefore, that is my answer. Alright, so here we're going to get rid of the x's because it has a 1 coefficient. So I'm going to write write down 3x plus 2y minus 5z equals 2. I'm going to write down x minus y plus 2z equals 1. And then I'm going to write down 2x minus 4y plus 3z equals a negative 3. And x minus y plus 2z equals 1. And I'm going to get rid of the x's, which means I'm going to multiply the bottom here by negative 3. And we're left with 3x plus 2y minus 5z equals 2. Same thing up top, but on the bottom, negative 3x plus 3y minus 6z equals a negative 3. And when I combine my like terms here, the x's cancel. I'm left with 5y minus 11z equals negative 1. And I'm going to use that down the road. Here, to get rid of my x, I'm going to multiply the bottom by negative 2. So I recopy the top equation and distribute the negative 2 through the bottom. Negative 2x plus 2y minus 4z equals a negative 2. And when we combine our like terms, the x's cancel again. Negative 4y and 2y is negative 2y. 3z and negative 4z is a minus z. And that's going to equal a negative 3 and a negative 2, which is a negative 5. So now we've created a system that we should know how to do. 5y minus 11z equals negative 1. Negative 2y minus z equals negative 5. I chose to multiply the bottom here by negative 11. So we end up with a 5y minus 11z equals negative 1. Here we get 22y plus 11z equals a positive 55. And when you combine like terms, you get 27y, the z's cancel, equals 54. And my y equals 2. And that's my first answer. I'm going to scroll down here a little bit so I have some more room. Once my y equals 2, I'm going to plug back in to one of my two systems of equations. So if y equals 2, I'm going to use negative 2 times 2 minus z equals a negative 5. Negative 4 minus z equals a negative 5. Add 4 to both sides, negative z equals negative 1, and therefore z equals 1. And then we go back to an original. X minus 2, I'm plugging the 2 in for y, plus 2 times 1 equals 1. X minus 2 plus 2 equals 1. Negative 2 and 2 is 0, so my x equals 1. And my answer is going to be x equals 1, y equals 2, and z equals 1.